Thank you. Everyone hear me? More value? Well, thank you for coming. I'm going to be talking about entity framework today, particularly code first entity framework. The topics I'm going to cover tonight, basically code first versus model and database first. Now I'll kind of go into the conventions that entity framework uses in code first. And then I'm going to talk about two ways to override those conventions. The first being using the data annotations library, and then also using the Fluent API that code first provides. Finally, I'm going to talk about the different types of relationships that you can have in your entities, the one-to-many, many-to-many, one-to-one. I'll talk about how you can load related data using those relationships, either eager loading or lazy loading. And finally, I'm going to give an interactive demo of database migrations. All right, so Entity Framework is Microsoft's data access technology they introduced a few years ago. It started in the first version. They provided database first and model first, which database first basically start with a database. You use the designer that's built into Visual Studio, kind of that drag and drop designer. And you basically, database first, you start with the database, and then you use the designer to kind of pull in your tables to build your entity models that way. And then kind of the opposite of that would be model first, where you start with the entities in the designer and have it build out your database. With the release of, I think it was 4.1 Entity Framework, they added what they call code first. Basically, you write all the code using just plain old POCOs, plain old CLR objects, and you typically start with the model in that case. You don't have to. You usually use it to generate your database for you by writing the classes. But a lot of people kind of still use it, even when the database already exists, just because you get the nice plain old CLR object approach to that. And one of the nice things about it is all the configuration is in code, versus with database first and model first, all that is in kind of those XML files that the designer has. All right, so I kind of mentioned it, but Entity Framework Code First is a heavily convention-based framework. And what I mean by that is you can write your entire model without a single line of configuration code, and it'll work out of the box that way. It uses a lot of built-in conventions to, example would be your table names are going to be based on your class name for your entity, and it's going to pluralize the table. So if I have an entity called customer, it's going to create a database table called customers in the DBO schema. So if you don't want to actually override those conventions, you don't have to write a single line of configuration for it. It'll just work out of the box. If you do want to override that convention, basically you would go down the data annotations or the Fluent API. A few other examples of the conventions that are included by default. Your entity, your primary key of your table is going to be based on the class name. So if I have, again, a class called customer, you have two options there. You can either have your primary key be a property called ID or the class name ID. So if your class is customer, it'd be customer ID. So excuse me, that would be the primary key of your table. A few other conventions would be the data types are going to be inferred from what your .NET types are. So for example, a string by default is going to be nvarchar max, so Unicode and then the max length. Again, you can override those, but if by default you only it's going to treat them as nvarchar max. Int32 is going to be an int. Int64 would be a big int. I think a short would be a small int, and then a byte might be a tiny int. I'm not positive on that, but and then a boolean would be a bit, etc. And I think decimal would translate to decimal and SQLite. I don't remember the exact precision, but we can check that later. Again, you don't have to have any configuration. So even if you don't include a connection string in your application, it will use a default convention to create a database within, I think, starting with Visual Studio 2012, it would be local DB. I think it used to be SQL Express. And the actual the database it's going to create is the namespace of your database context, namespace dot class name. So if your namespace is foo and your context is foo context, it created a database called foo.fooContext. And then also the relationships, the multiplicity is inferred from the class relationship. So if I have a customer entity with a orders collection, it's going to treat that as a one-to-many by default if you don't have the relationship on the other side. All right, so given a default model, basically I have a customer entity, public class customer with an int customer ID, so that would be the primary key. I have two strings, first name and last name. So those when it creates this table, it's going to be, since my class is customer, it's going to create dbo.customers. Customer ID is going to be the primary key, and actually since keys will also be treated as identities as by default. So you see, it created the customers table with a first name and last name property. Those are both nvarchar max and nullable by default. And when I have a collection of order objects, which the order class has an order ID, a price, which is decimal, an int quantity, and a product ID, which is just an integer property. The orders table that it creates, again, has the order ID as a primary key identity field. The decimal the price per decimal it created is decimal 18.2, so that's the default precision for that. Quantity just treats it as an int, product ID as an int. And even though I didn't have a specific field for it, it creates a foreign key relationship in a default column for it called customer _ customer ID. So you don't have to have the property in your model. It'll create it for you, and then by adding the relationships, when you add a new order to your customer entity, it's going to keep track of that for you. So you don't have to worry about it if you don't want to. All right. So you see also the database thing that I created. You don't see the namespace, but the namespace was conventions. The context, actually I forgot to inherit from DB context, but you kind of get the point. Conventions context will be the database name, so conventions.conventions context. All right, so what happens when you actually want to override the default conventions? You have two options, like I mentioned. The first is data annotations, and if you're familiar with MVC development, it's very similar. It actually uses a lot of the same attributes. So if you're familiar with that, it's the same easy-to-use attribute syntax, similar to the MVC attributes of validation, like required, string length, etc. One of the nice things that it does give you is it both provides database configuration and model validation. So if I say that I have a string property, going back to my first name example, if I say the max string length is 64 characters, then it'll create the database as nvarchar 64. But then what it'll also do is when I try and create a new customer and I set the first name to something that's larger than 64, it'll actually throw a validation exception when I try and save the model before it ever tries to go to the database. One of the things that I see as a disadvantage is it's not quite as flexible as the Fluent API. And the configuration is tied directly to your code, so if you're kind of a purist in that respect, you might dislike it for that reason. So here's an example of using the data annotations. So I have I'm using the same classes as before. Public class customer with, this time instead of using customer ID, I just called it key. So that would be my primary key. And I'm using the attribute called key to signify that is the primary key. And then I also, I'm using the column attribute to say, I want to name the database column customer ID. So instead of having it created as key in the database, it's actually creating it as customer ID. Then I have first name and last name again. this time I put the required attribute on it, so instead of creating it as a nullable column, it creates it as a not null column. And then I also specify the string length of 128, so now instead of nvarchar max, it's going to create it as nvarchar 128. And then the last thing I did is I'm using the table attribute on the class itself, so I can specify, instead of pluralizing the name, so it would be dbo.customers by default, I want the table to be called customer, and then I'm specifying a schema of sales. So by default it would be dbo, but I'm overriding that and saying I want it to create it in the sales schema. So if you look at the generated database over here, you see sales.customer with 3 columns, customer ID, first name, last name. And then if you look at the order class, I do a lot of the same things. I have the table order in the sales schema. Again, I'm calling the primary key just key and putting the key attribute on there so it is treated as the primary key. And then I'm calling or configuring so the column is actually order ID. And then this time I specifically have a property to store that foreign key relationship. I call it customer key. So that would basically be the customer that this belongs to. And then I wanted to override the column name. So instead of having it created as customer underscore customer ID, I wanted it just to be customer ID. So I specify the column there and then tell data annotations that this is actually the foreign key to the customer navigation property here. So if you remember the last one, I didn't actually have, I had a collection of orders, but I didn't have the customer that it belonged to on the other end. So because you don't actually have to have both sides of the relationship present for code first to function. It really just depends on how you want to actually query it. Again here I have a quantity, and this is kind of what I was talking about. So in the database I can specify, or in the data annotations I can specify what I want this range to be on the in quantity. So I put range of 1 to 10. So if I tried to save a new order and put a quantity of 11, it would actually throw that validation exception at that point. Again, I left price just the default, so it creates it as a decimal 18.2. Again, it created the database name. It's using the default convention. All right, so the Fluent API, that is your second option for doing configuration. If you're familiar with other Fluent APIs, I know there's Fluent Validation. There might be a few other ones. It's becoming a lot more common now in the APIs ever since they introduced the Lambda syntax. So if you're familiar with that, it's basically a very fluent syntax, kind of English-like, if you will. And one of the nice things about that is, I mentioned that the data annotations, the configuration is tied directly to your entities itself. With the Fluent API, you can actually separate out that configuration, so your POCOs are truly POCOs. They have nothing to do with the database. So if you're into that, then you can actually separate out that configuration. And you have a lot more control over how your database gets generated. For example, with the relationships, by default, if you had a many-to-many relationship, with the data annotations, you don't have a lot of control over how that schema gets generated. Like for the cross-reference table, it'll just use the convention to basically create that. With the Fluent API, you actually have a lot more control over that. You have more control over the inheritance mapping. So there's a few different inheritance mappings you can do. One's called table per type, one's table per class, and the other is table per hierarchy. As far as I know, you can't actually do that in the data annotations. Don't quote me on that because I'm not 100% sure, but you have a lot more control when you actually want to do those scenarios. And the other thing that it gives you is, by default, another one of the conventions that Code First will use is it'll cascade your delete. So if I have my customer and I want to delete a customer that has orders, it'll actually, in the database, cascade those deletes. So if you don't want that functionality, you can actually turn that off as well. One of the downsides, though, to that is and I don't really truly consider it a downside because the validations that it uses, like with the attributes like range and required, it doesn't do that because it has no notion of that data annotation. So it doesn't play well, or it doesn't mix with MVC like you would normally do it. I don't really consider it a downside because a good practice is to always use view models for that anyway. So you'd have your jQuery validation, etc. So I don't really consider it a downside. So here's an example of using the Fluent API. It basically starts with a base class called entity type configuration, and that is a genericized class. So you pass it in your entity, so everything is strongly typed, and you'll get your IntelliSense basically when you start typing. So here I have a class called customer configuration. It's inheriting from entity type configuration of customer. So it's the configuration for my customer entity. In here, I basically, one of the first methods I'm using is hasKey. This is where I'm using, and again, this is the same entities I've used in the other two examples. So I'm specifying that I want the primary key to be the key property. So you see I'm hasKey. This is what I was talking about with the Lambda syntax, if you're not familiar with it. So I have basically a Lambda pk, and then that's the equal greater than sign pk.key. So at this point, I would have IntelliSense pop in. So as soon as I type pk dot, you're going to see all the properties that exist on the model. Then basically everything else I'm using properties. So for the property key, I want the column name by specifying has column name to be customer ID. And then I'm also specifying that I want it to have the database generated option of identity. That's actually not necessary because again, it's one of those conventions. But if you didn't want it to actually create an identity, you could specify none, and then it wouldn't actually treat it as an identity. Then you'd be responsible for setting your own values for the primary keys. Then for string properties, again, since it has IntelliSense, it knows exactly what type of field you're configuring. So you're going to get different methods based on the type. So if I'm doing a string property, which is the first name, it's going to have methods called has max length, is Unicode, etc. So I'm doing property first name, has max length of 128, and I'm specifying it is not Unicode with is Unicode false. So what that's going to do is it's going to create, instead of an nvarchar 128, it's going to create it as varchar 128. Then I'm also specifying using the is required that instead of being nullable, it's not nullable. Again, down here I have a property called timestamp, and I basically specify that it has a column named timestamp, and then it's a row version column. So basically, it's used for optimistic concurrency. I think that's another benefit of using the Fluent API that you don't have with data annotations. All right, and then finally, with the relationship, I'm basically specifying that the customer entity has many orders, and then I'm specifying the other side. I'll talk a little more about this later, but this is how it's saying that it's a one-to-many relationship. So it has many orders, and then that order has a required customer. And what I mean by that is you can't have an order out there without a customer. So it would basically be a nullable key versus a non-nullable key. And then I'm specifying that I want the key column to be customer ID. And that would be the case where you didn't actually have the column for, or the property for the foreign key. So if on my order class, if you didn't specify that it had a property called customer ID, you can still control what you want that foreign key to look like in the database. So I'm saying that I want that key to be called customer ID. Because by default, again, it would treat it as customer _ customer ID. And then I'm specifying finally that it will not cascade on delete. And then the table that I want, using toTable, the customer, or I'm calling it customer with the sales schema. And this is basically what my database context looks like at this point. I forgot in the first slide, so it might make sense if I kind of go over what the DB context is. So it all starts with the DB context class. That is basically your database. That's your connection to your database. So think of your context is how you query your data. You inherit from the DB context class, and that basically is the starting point for code first. I believe in the model first and database first, it actually uses object context. What DB context is basically it's a wrapper around object context. You can still get to it by casting your object somewhere. I don't remember the exact way, but you still have access to it, but it's a lot more simple version of object context, essentially. Then you see I have a public DB set of customer. What DB set is basically a single table in your database. Well, not quite. I guess it's a single entity in your database, because you can actually, if you want, split an entity into multiple tables, or actually have multiple tables go to one entity. So it's not truly a table in your database. It's more, depends on how you configure it. So it exposes this on-model creating method, and that's where you basically add all those configurations. So if you look back, just creating the class isn't actually going to add it to your data to your context. So you actually have to specifically add it. So I'm saying model builder that add configurations that add customer configuration and order configuration. All right. If anyone has questions, feel free to interrupt me at any point. If anything doesn't make sense. So relationships. Code first supports the typical database relationships, the one-to-many. Example of that would be you have a single customer has multiple orders, and that order belongs to a single customer. And basically you specify that in the Fluent API. The relationships are always configured the same way. You always have a has. You start with a has method, and then you go to a with method. And that'll make sense when I show you the code for it. But basically, with the one-to-many, you say has many and with required or with optional. So you can specify that a customer has many orders, and then that order has a required customer or an optional customer. So you could, if it was an optional relationship, you could basically have an order that doesn't belong to a specific customer. It's just hanging out there on its own. Also supports many-to-many, which in this example would be like I have multiple users, and each user can belong to multiple groups, and the groups can have multiple users. And you do that by basically specifying has many with many relationship. And again, one-to-one also supported. So example of that would be a single user has a single profile, and one of those can actually, either one of those could be optional. So I could say a user has a required profile or has an optional profile, and then similarly, if it's required, you can specify on the other end if it's required or not as well. So you can say that if I have a user, I have to have a profile, or if I have a user, the profile is optional. And I mentioned this earlier, but the navigation property is actually only required on one side of the relationship. So if I have on my user class, if I can expose the user profile, but you don't actually have to expose the user on the other end of the relationship. And finally, with the navigation properties, if you mark your property as virtual, that's going to basically tell code first that that property will be lazy loaded. So if the first time I access that property, it would actually load that data for you, as long as you're still within the context of your data context. All right, so this is kind of what I was talking about with the relationships. So given I'm in the configuration class, I can say this example would be on a customer. I can say has many orders with a required customer. And that would basically mean that both navigation, the navigation properties are exposed on both sides, and then I specify what the foreign key is, if it exists. The second one would be an example of where the navigation property does not exist. So my customer has many orders, and the the order requires a customer, but I don't actually expose that navigation property. So you see that this is just an empty method, the with required. Again, I'm specifying the foreign key. And then has many orders with required, and then this would be an example where you don't actually expose that foreign key property. So it basically looks the same pretty much all the time. It's also optional which side you want to configure the relationship for. So if you start, the top example would be I'm configuring the customer entity and saying it has many orders with a required customer. But down here, you can also say, if you're configuring the order instead, you can say the order has a required customer and that customer has many orders. So and that's that's why I'm saying you always start with a has method and then you end with a with method. So has many or has required, with many or with required, etc. All right, so a many-to-many relationship, again, if I have users and groups example, so I have a user has many groups and that group has many users. So what's special about that is basically code first can automatically create that extra table for you. So you don't actually need an entity for that join. People say cross-reference join table. I've heard a lot of different verbiage for that. So if you don't actually care about it, what it would look like, let me bring up the code real quick. So what that looks like, all right. Can everyone see that? Good. Okay. So my user class has a collection of groups, and if I look at the group class, that group has a collection of users. So that would be the many-to-many scenario. What you don't see is behind the scenes it would create a table in the middle that basically just has two columns, the primary key to both tables, or foreign key to both tables, and it would treat both of those together as the primary key. So you don't actually have to expose that table. If I query a user and select the groups, it's actually going to use that relationship, do the joins for you implicitly, and just select all the users or groups. Okay, so all right, so has many groups with many users, and then basically specify what that looks like. So the join table. So you can say map left key. I'm going to call that column user ID. The right key would be group ID. So since I'm configuring the user entity, the user ID would be the primary key of the user table. The group ID would be the primary key of the group table. And then I want the table to be called users groups. So it would create a table called users groups with the user ID column, the group ID column. And that's what it basically uses when you query it, and it'll automatically join to that for you. If you actually need like a many-to-many table that has more than just those two columns, you can do that, but you actually have to create a specific entity for it. All right, so one-to-one. Again, you have the has methods, so has optional. So if I'm configuring my user, I can say a user has to have, or does not have to have a profile, so has an optional profile, but if I do have a profile, that has to have a user. So has optional with required. And then again, the navigation property is only really necessary on one side, so has optional profile with required blank. Or I can say this would be if I'm configuring the other end of it, the group or the profile. I can say the profile has a required user with an optional profile. All right, so I talked about this before. The lazy loading, to support lazy loading, all you really have to do is on your entity, your navigation property, just mark it as virtual. code first will basically create code behind the scenes. It'll actually generate proxy classes for you. So whenever, if I query a customer, for example, customer is equal to customers.find with the key of 1. As soon as I access that orders collection, if I'm still in the context, if I try to do it outside of it, it's just going to throw an exception. But as soon as I access that orders property, it's actually going to write a query to pull back all those orders for me. So if you don't want to use lazy loading, a lot of people don't like lazy loading. They want to bring back the data in a single query instead of multiple queries, because it will generate a query for every time you any properties you access. So if I had a orders property and like an addresses property, and I access both of those, it's going to be separate queries, and then another query for just accessing the customer itself. So if you don't actually want to lazy load, you can actually eagerly load. And there's multiple ways to do that. So again, going back to my customer example, I have a collection of orders. So if you look at the query here, from C in customers, and then you can use this include method. That either takes a string or, again, kind of that fluent syntax with the lambda. So I can say include the orders when I bring back the customer, where customer ID is 1, select C. So basically, it's going to write a query that's going to bring back a list of customers and the included orders for that customer. So it's going to do the join to the orders table for you. Again, the second query is basically the same as the first. The only difference is it's strongly typed versus just being a magic string property. The first, if I were to rename the orders collection to orders 2 for some reason, then that would fail at runtime. So with the lambda syntax, basically, if I rename the property, it would actually refactor the code and rename this as well. So, and then the last way to do it would be if you actually wrote a projection query. I don't know if you can see this well, but from C in customers, where customer ID equals 1, I can basically select an anonymous type, or if you have a DTO, like a specific class for it. Here I'm doing an anonymous type saying the customer is equal to C, and then the orders is equal to C.orders. So basically the query at that point is going to be a collection of anonymous types with the customer and orders collection. All right, this will be the final topic, database migrations. So with the I think version 4.3, I think it was, with Code First, or just Entity Framework in general, they added what they call database migrations. When Entity Framework was first kind of released, it kind of suffered from a pretty big drawback of if I'm using it to create my database and I make a change to my entity model, as soon as that change gets made, you had only a few different options. You could either have it drop your database and every time you ran your code, or you could have it drop the database whenever your entity model changes, or you could not do any of those and do it all manually. So none of those are really ideal, because if you're especially in like a dev environment where you kind of have a lot of test data, having it drop your database every time is not good, because then you have to recreate all that test data. It did have a way to seed data, but again, if you had like specific test cases, you don't want to have to seed everything. It became very problematic. So they introduced database migrations, which basically allows you to kind of keep track of those changes in code, basically in your solution, to have it automatically update your database when you make those changes. Adding or enabling migrations is actually really simple. If you're familiar with the package manager console, which if you use NuGet, you might be pretty familiar with it. You only have, it's basically a PowerShell tool. So all you have to do is type enable migrations. That's going to enable the migrations in your project. And then anytime you update your entities, you just have to type the command add migration, give it a name, and then to update your database, you basically type the update database command. So the first step, basically enable migrations, you only have to do once in your project, and then every other time, anytime you add a new migration, you just do the add migration, and then when you're ready to update your database, type in update database. So with that, I will go into a demo. Is there any questions first, or everything clear as mud?
Just to clarify on the relationships.
Yep.
As far as which side you put it on, that's determined primarily by how you're going to query.
Exactly. So what Andy said is you don't have to have the navigations on both sides. It doesn't hurt to have them on both sides, but it really depends on how you actually want to write those queries. So in the customer and orders example, more than likely you probably want to get a customer and query those orders. You would never start with the order. You would start by querying the orders and then find out what customer. It's up to you how you want to do it, but it really just depends on how you actually plan on querying the data. It doesn't really hurt to have it on both sides, so I usually do, but it's not necessary. All right, so migrations. Okay, so I have a very simple solution here. I'll show you the context real quick. Okay, so public class migrations context, it basically adheres to my DB context, so that's the exposure to my database. I have a public constructor here that basically specifies what connection string I want. And then I have my on-model created here. So I have one database entity in my project that is person. So I have a person ID, a first name, and a last name. And then I'm exposing that entity here. So basically a DB set of person, calling it people. So if I look at right now, so I have Management Studio open. If I refresh my list of databases, I don't actually have a database yet. So just wanted to show you that real quick so you don't think I'm pulling a fast one on you. All right, so again, to enable the migrations, all you have to do is in Package Manager, let me zoom in. All right, so type in enable migrations. All right, what it does real quick is it creates a single class called configuration in my solution. So if we look at it, creates a migrations folder. Inside that folder, you see configuration.cs. Basically, this is just this. This is where you can seed your database if you want to actually every time you create that database, you can or actually not even anytime it updates the database, it will actually run the seed method. It has they added a new extension method on here called add or update on your entity. So if I, again, my example is people. So I have my context dot, so context.people.add or update. So this is a new extension method that it exposes. So I can say add or update. The first parameter to it is basically how you want to specify if it's an insert or an update. So if I say new first name, last name. All right, and then then it basically takes in a variable collection of people that you can add. So if I have new first name equals S, last name equals else, and then maybe Matt. Okay, so all right, so at this point I still don't have my database. I'm just adding some data that will get called when I seed it. So the next thing, basically, when I have the model the way I want it to create the database, in the package manager here again, you type in add migration, and then you give it a name. So I'm going to call it initial migration. So every time you call add migration, it's going to create a new class in the solution. You see it basically puts a timestamp on there, and then the name of the migration I used. So it creates two methods in that migration. The first one's called up, and the next one's called down. So the up method is going to get called when it actually needs to migrate to the version to this migration, and the down method is called if I need to roll back that migration. So it actually supports being able to like if I wanted to migrate to the latest version, and then I found an error in the migration, I need to roll back. Basically, it would do both. So you see, it created some code for me. The first create table, basically dbo.person, and then it adds each of these columns in here. So person ID is equal to an int, identity is true, and then first name string, last name string, and then primary key person ID. So let's say I found a mistake in this migration. I actually wanted first name and last name to be max of 128 characters. So I can actually go back and say, you have two options. You can either change it in the migration or go into your configuration. So model builder.entity person. So for property, first name has max length of 128. And let's say that's actually a required field. It is required. Let's do the same thing for last name. All right, so recompile here. So what you'll do here is actually, you have two options. You can actually have it create another migration, or let's say I just didn't want my initial database to be wrong, so I could delete this migration. So delete, and then run that command again. So add migration, initial migration. So now when it created it, it basically says first name is equal to a string with a max length of 128. And if you wanted to do other things such as make an index on like the last name field or the first name field, you have that option here too. So you see .foreign key or .index. So if I wanted an index on a column, I could put an index on the column. And if you actually if it doesn't actually expose what you need to do, there's also a just a SQL method. You can run any SQL statement. So if you wanted to put maybe some other type of constraint that's not supported within that API, you can do that as well. All right, so I still don't have my database. So let's go ahead and. Okay, so just to show you, I still don't have my database. I will refresh this. All right, so these are actually the databases from the other stuff. All right, so let me go ahead and in Package Manager type in update database. All right, so you see it applied the code base migration, initial migration, and it ran the seed method. So if I refresh this again, you see now I have a database called EF Migrations, and that came from my app config. I said default connection should be a database called EF Migrations. So if we look at the tables, or the table, we created one table, dbo.person with column person ID, first name with nvarchar 128, and last name of nvarchar 128. So if I were to run my code, actually we'd, real quick, let's prove it actually ran that seed method. So I will add a new connection. If you haven't used LinkPad, it's actually a really, really sweet tool for basically running queries. You don't actually have to have Visual Studio and like a test program to actually run queries against. You can just download this tool. It's free. There's a paid version that gives you IntelliSense, but without it, it's still pretty awesome. So I would add a new context, DB context. So go here and choose the assembly that exists in. So I think this is right here. So you see, it found my migrations context in there, and then All right, so give it a name, migrations. I can test the connection here real quick. All right, successful. So now, basically, it you see my one data DB set in there, so I can actually right-click this and say people, any one of these options, people.take 100. So it's going to run that query for me, and you get a nice visualizer that shows you, okay, Travis, Ellis, and Matt Rear are actually in that people table. So up to this point, we really haven't run into the reason why you need the migrations, because by default, you got this same behavior in the original versions, because I'm just creating my database. So now let's say I want to add a new column to this table. Let's call it email. Email address is a good example. So go back to my person entity. I will add a new property. Oh, string email address. All right, so add that, and let's see here. Add a new migration. So add migration. Add email to person. All right, so automatically detected what those changes were. So you see it has a add column method now on dbo.person add email address. Email address column, and it's just a string. So then when I go down, it can actually drop that column. So it's still, if we check the database, I refresh this, it's not actually in the database yet, so because I haven't actually applied the migration. So if I were to go here now and run the update database command, it's applying the migration and running the seed method. So now if we were to refresh, you see email address, it's an nvarchar max. And if we were to run, run the same query again. Now I see person ID, first name, last name, email address is null now. So now we can see the kind of the power. I didn't have to drop the database to do it. It just added a new column where the old one would be to either drop the database every time you ran or drop it whenever your model changes. Neither one of those were really ideal. So if we were to go look at our configuration class again, our seed method, let's say we actually wanted to populate that email address property. So go in here, and I can say email address equals Travis Ellis deliveron.com. All right, so I've already applied the migration, but if I just type in update database again, it's going to know that it's already there, but the only thing it's going to do is run that seed method. So you see no pending code-based migrations running seed method. So if I were to go query that again, now I have an email address. So I didn't actually have to drop the database, and that's what I was talking about before with that seed, the add or update method. I'm specifying that to find an existing person, look at these two columns combined. So first name, last name. So since there was already a person called Travis Ellis in there, it did an update statement instead of a insert statement. All right, so you have a lot of different options. So again, let's say I found an error in my new column. So I didn't want no email address ever needs maximum amount of characters. So let's say I want to change that. So I can go in here. Again, you could just add another migration to change it. But let's say I want to actually create the migration right. So I can specify that I want to actually roll back that change. So I can type in update database, target migration is equal to initial migration. Initial migration. All right, so now you see instead of updating the database, it says reverting the migration. And now if I were to look at the database, refresh that column list, it is actually gone. So it dropped that column, and then all the data. One of the something you can't really get rid of is if you did have data, it's gone. You're not going to be able to, revert that change. I guess with the transaction line, I don't even know if you would be able to that way because the column's gone. So yeah, you're gone. So
the database.
yeah. So
How does it know what version of the database you're on?
oh, good point. So if you look at there's the system tables folder, it actually creates a migration history table. And basically every time a migration is added, it'll insert a new row into there. And that's basically whenever it runs the query, it'll check to see if it's the latest migration or not. So if you don't want to actually apply the migrations through Visual Studio, a lot of DBAs might be hesitant to do that. It's probably fine for like a dev database or maybe even a testing database. For production, they probably want scripts, so you actually do have that option as well. So let me go back and actually change my migration. Again, I mentioned before you can actually do it here. So if I specify max length. So let's say I want max length of 256. So I just changed the code file. I didn't actually change my configuration. So I would probably prefer to keep them in sync, because it'll always look at the configurations you add in your context to build the migrations. So if you just change the migration without actually changing that, they're kind of out of sync, even though the database would always be using the migrations to run. So I would just prefer to keep them in sync. So do that at your own risk, I guess. But so if I were to reapply this migration, update database, I don't need a target since it's. All right, so now we look at the columns again. So now its email address is nvarchart 256. Like I mentioned though, if I actually don't want to update the database in Visual Studio Package Manager, so target migration, you actually have a script option. So if I were to type in update database, target migration, actually I don't even need that. I should do script, -script. So it'll take a second here, and then I actually create a script for me that I can basically give that script to a DBA, and it'll do exactly what the Visual Studio Package Manager is doing. The one thing I don't think it does is it's not going to run this. It's not going to create scripts for the seed method. So if you need that, then you'd probably have to either do that manually or I'm not sure if there's a way to actually generate the script for the seeding. So so you can basically hand that to a DBA. Again, let's add another entity. Maybe I'll add another entity to our project. So so here add class. So address. Zoom in. Click its address ID. Line 1. All right, so add a new class, and by default, it's not actually going to have any relationship with person. So let's add a collection to the person entity. All right, so since I associated it, I don't actually have to expose the address in my context. So if I were to look at the context, I still only have people exposed. But since there's a relationship between person and address, it'll actually know that it is a new entity and a new to-do table, etc. So if I were to add new migration, actually I'm going to have to update the database again. So it only basically allows you, so if I were to try and add migration now, add address. Basically, you're going to get an error because you're not on the latest version of the database. So what I have to do real quick is update database, and now I can add my new migration. All right, so added the new, basically created a new table, addresses with my columns, adds a primary key and a foreign key to my person table, and then it actually created an index on the foreign key column. And then basically it has the down method where it drops the index, drops the foreign key, and then drops the table. So now let's say I want to update my database again. So database. So now if I were to go into like that. So let's say from P in people, where p.person ID equals 1, select P, and I'll do P, person equals P, addresses equals P. What did I call it? Just address? That doesn't make sense. Let's just change that. There's multiple. All right. All right, so this is kind of what I was talking about before. If I want to eagerly load the addresses with the person, I can do basically a projection. So select new, person is equal to P, and then the address is equal to P.addresses. I can similarly do a query where let me just copy this. Instead of doing a projection, I can say P.include addresses. All right. One of the other really cool features of LinkPad is it actually shows you the SQL that it's generating. So it's really helpful for kind of testing those queries without actually having to update, recompile the code, and then like kind of do a trace in SQL Server. You can actually just see exactly how it's generating that code. So select, you see all the columns that it's selecting. It's doing a subquery and doing a left outer join to the addresses table. So let me just change the seed method real quick to have an address here. See. All right, so let me update my database just to run the seed method. So now if I run that same query again, you see no addresses for sure. Right now. Right, because it's not exposed. Okay. quite sure why it did not. Oh, it's probably not realizing that. Let me just delete that data. So if I run that again, hopefully that'll work. Alright, so now it's in there. So if I would go back to my query. Alright, there we go. So go back to my projection. So basically from people include addresses where person ID equals 1, but B. Oh, correct. No, it's probably 3. All right. So you see, I'm now in there, and it has included my address as well. So, so finally, I guess, so let's say your dev database, you're always up to date when you're developing, but let's say you only release to production every few months. So production is actually a few versions back, so you can actually have it generate a script to apply multiple migrations. So if I were to go back here and say, so let's say production is on the initial migration, or you don't even have to have any at all, but so update database, so target migration is equal to, what was it called? Add address to person. And source migration is equal to initial migration, then the dash script option. So you're going to see it is going to apply 2 migrations now. And the script it creates has both of those migrations. So it first has to alter the person table to add email address, and then insert to the migration history table, and then it runs the migration to create the address and basically add the migration at that point. So you can give that to a DBA. They should hopefully be happy. Maybe not too happy since they don't like Entity Framework too well, but then you're good to go. So that is the demo on migration. So there's also actually another option. So let me just show that real quick. So it does also have the option to, I mentioned this before, but let's see. If you actually want, when you actually run your code, that it'll just apply any migrations it needs to. You can use what's basically called a database initializer. So let me zoom in. So if I say database dot set initializer, and I believe it's apply. I don't remember what it's called. Do you remember what it's called? No?
I think that's your context, right? The
Yeah.
generic-
Actually, oh yeah, that's your context, right? Oh, there we go. That's what it was. Migrate. So basically, it's called migrate database to latest version. So basically, anytime you run the code, it's going to first query that migration history table. If it determines that it's not actually on the current version, it's going to apply any migrations it needs to get to that point. One of the things I don't really like about that approach is every time you run that context, it actually has to run a query to check that. So it could potentially be a performance hit, but I don't know how big, just because it's just a small query to select from a table. But you do have that option if you want. And the other ones I was talking about, drop create database always, drop create database if model changes, and I think there's also like a don't do anything for, there might be a fourth one, I can't remember at the point. But you do have that option if you want to. When you run your code, it'll actually just automatically apply those changes for you. So, any questions, or I've already enough already? All right. Well, is anything else, or?
Yeah, we have some prizes for this thing.
All right, prizes. You wanna bring
Thanks
that?
for